Hi, we are JatGPT representing leveling up with data science, player retention in the gaming realm. According to Statista, the Philippine gaming industry earned 78 trillion in 2020 and is expected to grow up to 121 trillion by 2027. There is a massive market that can be taken advantage of by local developers such as the Game Developers Association of the Philippines. However, even with the home field advantage, Filipino developers have a hard time finding success in the market, leading us to the problem. The Philippine gaming industry is highly valued, but local game developers struggle to succeed as stakeholders within the ecosystem. So, how does the typical player journey start and end with games? People who want to play a game will buy it and then they will play it to completion or stop playing the game. The key here is player retention, the number of players engaged with the game. A high retention rate means players are engaged. It promotes community building, which can be used as a source of user feedback to ensure the success of current and future games.
For our methodology, first we gather data from two primary sources. We leverage the Rogi API to obtain a comprehensive list of games and its corresponding game developers. We also scrape data from the Steam API to gain insight into the cost of various games available on the platform. After acquiring the data, we merge the datasets obtained from the two different APIs. Then we clean this dataset by eliminating duplicates and by handling missing or null values to ensure the reliability and accuracy of our model. With a clean dataset, we move on to EDA. Here, we used correlation plots to understand the relationships between different variables. We also implemented outlier detection using the isolation forest to ensure that our model would not be swayed by extreme values. We then move into the phase of feature engineering, where we created new variables from existing features. This stage also involved selecting the most relevant features for our predictive model. For our model building stage, we experimented with 8 different ML models to find the best fit. Furthermore, we applied resampling methods to balance our dataset and hypertune the parameters of the selected model to optimize performance. The final step was to evaluate the chosen model. This involved identifying the most significant features and interpreting the model's decisions using SHAP values to get a deeper understanding of the model behavior.
After identifying the relevant features, correlation among numeric features was assessed using a correlation plot. Beaten or finished has a high correlation with the number of reviews, but was still retained as it is used to compute for retention. The feature meh was observed to have a high correlation with the feature dropped. However, as other features related to customer ratings, such as exceptional, recommended, or not available, it was decided to exclude meh and retain dropped. Results show that ratings count is highly correlated with reviews count as they refer to the same metric, hence, ratings count was excluded.
Our dataset was sourced from two major APIs, Rogi and Steam. The Rogi API provided us with a list of 30,251 games and its corresponding game developers. The Steam API offered us a data on the cost of these games which are available on their platform. After thorough pre-processing and cleaning of data, we were left with a total of 13,280 games. The significant reduction in the number of games from the Rogi API is due to missing values. Some games had missing cost, while others lacked information about game genres and player types. To ensure data integrity, we removed these entries from our dataset. The features we use can be broadly categorized into three types. Target feature, which is the retention tag if a game has greater than or equal to 10% retention rate. Numerical features, such as number of reviews, player behavior, and cost of the game. And lastly, categorical features such as game genre, console availability, market availability, franchise and developer, and player type. A total of 57 columns were used for the ML model, and the combination of these different types of features gave us a versatile dataset to train our model on.
After training the clean data on various models, gradient boosting classification emerged as the best model. Here are the specifications of the model. Random oversampling was used, and learning rate and estimators were the hypertude parameters. Resulting recall scores of train, validation, and holdout datasets range from 81.9% to 85.7%. Analysis using Shapley values showed which features have the highest impact on model prediction. The feature importance plot shows that the number of features contributing to the prediction of the model are to play, number of reviews dropped, and playtime. The graph on the right shows how high or low values of the features affect the model's prediction. It can be observed that the higher values, shown as pink streaks on the plot, of the features to play, review count, and playtime all contribute to the positive prediction of the model. Meanwhile, the third most important feature dropped has a negative impact since its higher values result to a negative prediction.
Now let's proceed with the conclusions and recommendations. According to our findings, to play is the most influential factor. Hence, we propose that developers need to leverage marketing strategies that spark player interest, aiming not just to meet but to exceed customer expectations. A case study illustrating this perfectly is Death Stranding. The game's promotional strategy went beyond simply highlighting the participation of high profile individuals. It was marketed as a Hideo Kojima creation, cultivating an aura of intrigue and expectation around it. When the game was released, customers were satisfied with the game, and up to this day, Death Stranding is still very popular to the gaming community. The second most impactful feature of the model is the number of reviews a game has garnered. This serves as an indicator of a vibrant, engaged community around the game. That's why we strongly recommend that developers actively participate in community building efforts. This involves not just creating spaces for player interaction and discussion, but also fostering a sense of belongingness and inclusivity among its players. A shining example of robust community building can be seen with Portal 2. Launched back all the way back in 2011, the game boasts an enduringly active community up to today, a testament to successful community cultivation. This sustained engagement has led to the creation of new gaming content and kept Portal 2 in high regard over the years. The dropped column is another crucial aspect. Notably, games with higher drop rates often exhibit addictive traits, issues within the community, and excessive banning. For a game to achieve high retention rates, we recommend that developers foster a climate of healthy engagement within their gaming communities. This includes ensuring that the game isn't designed to be overly addictive, curbing negative community behaviors, and implementing measures to discourage offensive language. An example that underscores these points is Dota 2. Despite its enormous popularity, international acclaim, and deep cultural penetration, the game is infamous for its issues with player bans, toxic community, and addictive nature. Finally, the playtime feature. Our data suggests that games with longer playtime typically have a higher retention rate. We recommend to developers to prioritize not just quality but also quantity. When a game offers multiple layers to explore, a compelling storyline, a sense of progress, and numerous achievements to unlock, it heightens player engagement. Essentially, the more there is to discover and the richer the gameplay experience is, the higher the retention of the game. Red Dead Redemption 2 serves as a good example of this dynamic. Its success can be attributed not just to the high quality development and captivating narrative, but also to the vast array of experiences it offers to the players. Its depth of content and extensive playtime have contributed to its immense popularity.
So, how can the results of the machine learning model help the Filipino game developers? The model has pointed out four significant factors that influence high retention rates of video games, namely to play, review count, drop, and playtime. Now, let's take a look at 10 games recently released by the Game Developers Association of the Philippines, or the GDAP. We observed that only 3 out of these 10 games had any substantial presence on social media, leading to a reduced reach and low public awareness. Social media platform offers an affordable, if not free, marketing channel, and developers should seize this opportunity to extend their reach, connect with potential users, and build a loyal customer base. Another crucial factor is the perception of the game's ongoing development and support. A case in point is that many promising games from Filipino developers suffered from a perception problem, infrequent updates that lead to a misunderstanding that the game had been cancelled. This indicates the vital role of regular updates and constant engagement with the player community. Thus, by maintaining a robust social media presence and keeping your player community engaged with frequent updates, developers can better ensure that their games are not just played but continue to retain a vibrant and active player base. These are straightforward yet powerful strategies that can have a significant impact on the success of the games. Now, for enhanced game development, we suggest diving deeper into time series analysis. This includes understanding playtime trends, in game purchase behavior, and strategizing user segmentation. Additionally, harnessing NLP or natural language processing can gauge the game's social media impact and decode players' feedback from live streaming sessions. By focusing on these areas, we can better equip ourselves to navigate the evolving landscape of the gaming industry and build games that resonate with our players while ensuring sustained success. We have developed a predictive model to gauge a game's player retention rate. It considers multiple features including review count, average playtime, player intentions, game cost, genre, console availability, marketplace distribution, franchise status, and the reputation of the developer or publisher. It also factors in the type of gameplay, be it single or multiplayer. Our model provides an extensive view into what may influence a game's success in retaining players. You may scan the QR code to view our Streamlit app to know more about our project. And we are ChatGPT, and thank you for listening.